Today we're dealing with concepts called complex numbers. And to build up to this concept, I want to kind of start with a couple of explore problems first. So this first explore problem, what numbers can you square to come up with 16? So when we square, we say, all right, what number times itself will give me 16? And the first thing we can think of is 4 times 4, right? Or another way to write that is 4 squared. That would equal a positive 16, right? Well, so that's a positive times a positive. Another way that we can get that, if we wanted to, was use negative 4 squared. So if we go negative 4 times negative 4, we'll get a double negative, which will come out to a positive and give us 16. So another way to write that would be negative 4 squared. Now, if we were to look at explore problem 2, what numbers can you square to come up with negative 16? We can try a couple things, right? I know that I would need a positive and a negative number to get there. So I could do 4 times negative 4 would give me negative 16. However, that doesn't really square the number, right? You had 4 times a negative 4. It's not really squaring it if it's not multiplying it by itself, so that doesn't work. And if we start to explore some other options for maybe how can we get to 16, we could try 0 times 0, but anything times 0 is going to be itself. We can maybe try some decimals to work our way there, but none of it's going to land us at 16. So we really need because of this questions, mathematicians kind of developed this concept of imaginary and complex numbers to help us deal with that. So let's get this definition for imaginary number down on our note sheet, as well as this green box defining this letter I. So first off, an imaginary number, when squared, imaginary numbers give us negative results. Exactly what we were looking for in explore problem 2. They're always going to include the imaginary number I. So I is defined as it's the square root of negative 1. And when you square it, it's equal to negative 1. Now, let's see how this can be used in a couple of examples here. So, in example 1, we have the square root of negative 9. Now, square root of negative 9, if we were to kind of expand out, let me back up here. The square root of negative 9, we can take this using I by basically pulling out the I based on that negative sign there. Okay, so we'll take I and the square root of 9, and now I is outside of that square root sign. Then we can actually take the square root of 9, which is 3. And so in this case, we'll get 3I. And no need to write this green part on your note sheet, but if we want to look and prove why this works, we get the square root of negative 9. Okay, we can break that into the square root of negative 1 times the square root of 9. And if you look at the definition of I up here, I equals that square root of negative 1. So we can rewrite this again as I times square root of 9. You can take the square root of 9, which is equal to 3. So let me erase that real quick. I times 3. And we would rewrite that just like we would with any other variable. We'd write it as 3I. So similarly, in example 2, we can find the square root of negative 36. We have a negative square root number, so we are going to take out the I from that. We'll have the square root of 36 times I, and we can actually take the square root of 36. Okay, what times what, or what times itself gives me 36? That would be 6, and our answer would be 6I. We can also work the other way with I, where we're using this definition, the second kind of definition below here, where I squared equals negative 1. So if we're given 16i squared, we can first kind of replace that I squared with -1. So 16 times -1. And if we have -1 times any number, it's just going to be that number with the opposite sign. So in this case, we'll get -16 as our answer. Let's try this again on example 4. We have 5i squared. Basically, if you get an I squared, it flips the sign of that number when we use up that I squared. Let's step it out real quick. We get 5 times -1. So we'll just get -5. So these imaginary numbers are part of larger numbers called complex numbers. This is another definition. Let's get down on our sheet as well as the info in this box here. Complex numbers are going to be the combination of a real number and an imaginary number. So if you look over here in our box, we have a real part, which will be out in front usually. It won't contain the I at all. And then added or subtracted with an imaginary part, B, which will contain the I term. So let's see how we can identify these complex numbers and the parts of these complex numbers in example 1. So we have 1 plus 2i. Now the real part is going to be 1 here because it does not include I in the term. So we can write real equals 1. And the imaginary part is going to be this number 2, okay? And it's important that we don't include I in that. We basically want to know how big is the imaginary number. And in this case, it is 2. Not 2i, just 2. All right, let's see how this plays out in example 2 here. We have 8 minus 3i. So the term without the I is this 8 here. So our real part is equal to 8. And the imaginary part here, it has a negative sign out in front of it, right? And we are subtracting that 3. So the imaginary part is going to be equal to -3. Again, not -3i, just